From the sun's core to how plants make food, nature shows us how energy changes form. For ages, we've tried to copy nature, to learn how energy works. Now we're entering a new time where quantum mechanics might give us a never-ending energy source, the quantum vacuum. For many years, scientists have thought that space-time itself, the quantum vacuum, holds massive energy. It's like a giant hidden ocean of power. What if we could use this energy to power our world cleanly and forever? Join me as we explore quantum energy and the McGinty Equation. We'll look at tiny particles appearing and disappearing, which might hold the key to clean energy. Our journey starts with fractals, patterns that repeat at smaller and smaller sizes. These patterns are not just beautiful, they are fundamental to the structure of the universe. From the veins in a leaf to the rugged edges of a coastline, fractals are everywhere. Like a coastline, which looks complicated but follows a simple rule, fractals can be found in the most unexpected places. These seemingly chaotic shapes are actually governed by mathematical principles. The quantum vacuum, the very fabric of space, has secrets hidden in fractals. These tiny repeating patterns are not just theoretical, they have real-world implications. Think of a tree's branches reaching for the sun. Each branch splits into smaller branches, and those into even smaller ones, all following the same pattern. Each branch is a small copy of the whole tree, making it strong and resilient. This self-similarity is a hallmark of fractals, providing both beauty and strength. Fractals, with their repeating patterns, can interact with the quantum vacuum, making its tiny energy bigger. This interaction is not just a curiosity, it has practical applications. This tiny energy, called zero-point energy, is always there. It's a background hum of the universe, a sea of energy that we are only beginning to understand. Fractals act like antennas, collecting this energy like a magnifying glass focuses light. By harnessing these patterns, we can tap into this ever-present energy source. This connection between fractals and the quantum vacuum is important for energy. Imagine the possibilities if we could efficiently capture and use this energy. Imagine solar panels, not flat but shaped like fractals, collecting sunlight and the energy from the quantum vacuum. These panels could be far more efficient than anything we have today. Imagine cities powered by buildings with fractal antennas, seamlessly integrating with the environment and drawing energy from the very fabric of space. Or cars fueled by space-time itself, reducing our reliance on traditional fuels and moving us towards a more sustainable future. This is the potential of fractals, connecting nature's design with quantum energy. But there's more. These patterns could revolutionize technology, making it more efficient and in harmony with nature. To understand the McGinty equation, we need to look at gravity, a force that shapes the universe and bends space-time. Where space-time bends around heavy objects like black holes, we see the profound effects of gravity. This bending of space-time is a key to unlocking the mysteries of the universe. Gravity rules the universe, shaping galaxies and stars. It is the force that binds the cosmos together, dictating the motion of celestial bodies and the structure of the universe itself. From the swirling arms of galaxies to the birth of stars, gravity is the invisible hand that sculpts the heavens. But gravity also affects the quantum world. At the smallest scales, where particles pop in and out of existence, gravity still exerts its influence. This intersection of the cosmic and the quantum realms is where the mysteries of the universe deepen. Think of Earth not as a solid ball, but as a dip in space-time, a curvature created by its mass. This curvature is what we perceive as gravity, a force that pulls objects towards the planet's center. This dip or gravity well is a direct result of Earth's weight. The more massive an object, the deeper the well it creates in the fabric of space-time. Like a bowling ball on a trampoline makes a dip, Earth bends space-time. This analogy helps us visualize how massive objects distort the space around them, creating the gravitational pull we experience. Now, imagine the quantum vacuum, not as empty space, but as a sea of tiny particles appearing and disappearing. This seemingly chaotic dance of particles is influenced by gravity, even at these minuscule scales. These particles are affected by gravity. The force that shapes galaxies also impacts the quantum realm, linking the vastness of space with the infinitesimal world of particles. Stronger gravity means a bigger effect on these particles. In regions of intense gravitational fields, the behavior of quantum particles can be dramatically altered, leading to fascinating and complex interactions. This idea that gravity affects the quantum vacuum opens up exciting possibilities. It suggests that by manipulating gravity, we could influence the quantum world in ways previously thought impossible. By making artificial gravity wells, we could control the energy of the quantum vacuum, harnessing it for practical applications. This could revolutionize our understanding of energy and its potential uses. Creating areas of high energy through artificial gravity wells could lead to breakthroughs in energy generation, providing new, powerful sources of energy. Imagine a machine that makes strong gravity. Such a device could bend spacetime and create regions where quantum energy is concentrated, offering unprecedented control over the fundamental forces of nature. This machine could bend spacetime and make an area where quantum energy is strong, pulling energy from the vacuum. This concept could pave the way for new technologies and energy sources. Pulling energy from the vacuum could provide a nearly limitless source of power, transforming how we think about energy production and consumption. This idea is new, but it could change how we make energy. By tapping into the quantum vacuum, we could unlock a new era of energy technology. If we can learn to use gravity and the quantum vacuum, we could harness a clean, unlimited energy source. This would be a game changer for our planet, providing sustainable energy for generations to come. We could have clean, unlimited energy, changing the world forever. The potential is immense, and the journey to harness this power is just beginning. The future of energy lies in the fabric of space-time itself. Beyond the veil, unveiling hidden dimensions, we see our universe with 3 space dimensions and 1 time dimension. But what if there are more dimensions, too small for us to see? String theory suggests our universe might have 10 or 11 dimensions. These extra dimensions are curled up and hidden. Imagine a tightrope walker. From far away, the rope looks one-dimensional, a line, but to an ant on the rope, it's a whole world around the rope. Similarly, these extra dimensions, though invisible, could affect the quantum vacuum's energy. Like the shape of a drum changes its sound, the shape of these hidden dimensions could change the quantum vacuum's energy. Some theories say these extra dimensions hold huge amounts of energy. If we could access these dimensions, we could have unimaginable power. This is the exciting possibility of the McGinty Equation, a guide to higher dimensions. By understanding these hidden realms, we might unlock the energy of the multiverse. Nanoscale architects shaping the quantum world. In the quantum world, size is everything. At the nanoscale, the normal rules of physics change. Tiny particles can be in many places at once and go through walls. Imagine a world where we can control the smallest parts of matter, building things atom by atom. This is nanotechnology. Scientists can now build things atom by atom, creating materials with special properties. These tiny devices are perfect for interacting with the quantum vacuum. Like a radio antenna picks up radio waves, nanoscale structures can be built to resonate with the quantum vacuum's energy. Imagine a tiny antenna, 1,000,000 times smaller than a hair, vibrating with the vacuum's energy. This tiny antenna could turn this energy into usable power. Or imagine a tiny capacitor, storing energy from the quantum vacuum like a tiny self-charging battery. These are just a few ways nanotechnology could help us use quantum energy. The quantum engine powering the future. The McGinty Equation shows us how to build new energy converters, machines that turn the quantum vacuum's energy into power. These converters are designed to harness the energy that exists in the very fabric of space-time, a concept that was once purely theoretical but is now becoming a reality thanks to groundbreaking research and technological advancements. Imagine a world where power plants don't use fossil fuels or nuclear power but get energy from space-time itself. This would mean a significant reduction in carbon emissions and a cleaner, more sustainable future. Cities could be powered by an endless supply of energy, leading to a revolution in how we think about and use power. This is the promise of quantum energy converters. These devices could potentially provide a nearly limitless source of energy, transforming our energy infrastructure and making power more accessible and affordable for everyone. One idea uses the Casimir effect, where 2 close metal plates are pulled together by the quantum vacuum. This phenomenon, first predicted by Dutch physicist Hendrik Casimir in 1948, demonstrates the presence of energy in empty space, a concept that has fascinated scientists for decades. By changing the distance between the plates, we might get energy from this effect. Researchers are exploring how to manipulate this force to create a viable energy source, potentially leading to new forms of power generation that are both efficient and sustainable. Another idea uses metamaterials, artificial materials with special properties. These materials can be engineered to have properties not found in nature, allowing them to interact with light and other forms of energy in unique ways. These metamaterials can control light and might be used to channel energy from the quantum vacuum. By manipulating electromagnetic waves, they could potentially direct energy flows in ways that were previously thought impossible, opening up new possibilities for energy harvesting. Imagine solar panels coated with metamaterials, absorbing sunlight and the quantum vacuum's energy, making them much more efficient. This could lead to a new generation of solar technology that not only captures more sunlight but also taps into the vast energy reserves of the quantum vacuum. These are just a few exciting areas of research in quantum energy. Scientists around the world are working tirelessly to unlock the secrets of the quantum vacuum and develop technologies that can harness its power. There are challenges, but the potential is huge. Overcoming these obstacles will require collaboration, innovation, and a deep understanding of quantum physics. But the rewards could be transformative for our society. The McGinty Equation guides us, offering hope for a future powered by the limitless energy of the quantum vacuum. As we continue to explore and understand this equation, we move closer to a world where energy is abundant, clean, and accessible to all. As we finish our exploration of quantum energy, we're left with a sense of wonder. The quantum vacuum, once just a theory, might be a source of clean, unlimited energy. The McGinty Equation shows us how to explore this amazing area, showing a future where we don't need polluting energy sources. The challenges are big, but the potential is too big to ignore. Trying to unlock quantum energy shows human ingenuity and our desire to learn. It's a journey that needs scientists, engineers, and dreamers working together. If we succeed, it will bring a new era of prosperity and sustainability, changing how we use energy and our place in the universe.